All right, so just like before, we are transitioning from confidence intervals to hypothesis tests. Um, the only difference is instead of doing one sample, we're doing two samples. Two samples, of course, being a little bit more laborious, certainly if you're doing the calculations by hand. Of course, the calculator makes short work of it, but at the same time more useful and probably a closer approximation to kind of how researchers are kind of using and applying statistics in actual practice. So here we are, hypothesis test for the difference between two means. That's all I really focus on. By this point, right, hopefully kind of extending it, for example, to a hypothesis test between for the difference in two proportions is really not that big a deal. I'm not skipping it because it's difficult. I'm skipping it just because we've probably had enough by now. And if we can kind of just perfect the basics of hypothesis testing, my personal opinion is that we're ready to move on to kind of some new kind of cool stuff, which we'll do in chapters 12 and 13. So how we perform a hypothesis test for a difference of means. Probably not surprising. Depends upon whether or not we know the population standard deviation. If we know the population standard deviations, we're going to go stats test to sample or to samp z test. But if we don't know the population standard deviation, we're going to go stat test to samp t test. And again, just like before, for our class, we will always select no for the pooled option. Pooled just is basically saying, do you think that the two groups have the same standard deviation? If we do think that they do have the same standard deviation, we could sort of pool the information between the two samples to come up with a better estimate of their common standard deviation. But again, in practice, probably the two groups have different standard deviations, or at least in practice, we don't know. So typically we would select no in practice, which is why I'm encouraging us to do it for our tests and our homework problems and so forth. I will say, right, those are the distinctions. I think all the problems in our book are two-samp t-tests. So I don't know that we'll get an example of a two-samp z-test, which is fine. Again, in real life, we never really know what the population standard deviation is. So in real life, we're doing t-tests anyways. So I think there's two problems from this chapter overall. Kind of a familiar pattern. First one's this kind of very generic, no context problem. And then the second one is a word problem. Of course, the word problem probably be a little closer to what you would see on a test. So here we're just kind of practicing the mechanics, the fundamentals. A test was made, null hypothesis, always a statement of equality that mu1, the population mean of the first group, is equal to mu2, the population mean from the second group. And our alternative hypothesis is that the mean of the first group is smaller than that of the second group, right? So I don't know, maybe we're comparing salaries between males and females, and maybe we think that for this particular demographic, the average salary for males is less than females, for example. So the sample means our x bar 1 is 6, x bar 2 is 11. The sample standard deviation, so I highlighted that myself. We see sample standard deviations, boom, that tells us we're going to be doing the t-tests. Our 3 and 5, our sample sizes are 10 and 20. So like I said, sample standard deviation means we're going to do sample t-test. We just fill all that information in. I think that I had to scroll down a little bit, so there's also a little bit of information I had to fill in at the top. I'm guessing maybe just the X bar 1 I filled in off the top and then had to scroll down. I had to pick at that last line, I got to pick what our alternative hypothesis is. In this case, our alternative hypothesis is that mu1 is less than mu2. And then, like I said, we're always going to pick the pooled no option. And I think we got to scroll down a little bit more, and then we'll see probably a calculate thing that we could click enter on. And that'll give us this information, right? So it gives us our test statistic, that's the t. Gives us our p-value, that's the p. gives us degrees of freedom, which in practice we don't typically care about, and then just reiterates some of the information that we already kind of input, the sample means, for example. And so there we go. I think that there's a part A that asks degrees of freedom, um, which we could have just read off the calculator, but no one really cares about those things in practice. I'm never going to ask you for degrees of freedom for this type of test on an exam. So don't worry about it. Instead, we get focused on the test statistic. Test statistic is negative 3.41. So what's that saying? It's basically saying that the sample mean for the first group is 3.41 standard deviations below or less than the second group. It's quite a bit. Our p-value, not surprisingly, is small. It's 0.001. We're told to use an alpha of 0.05, so we compare it to 0.05. In this case, it's less than 0.05. Because of that, we reject the null hypothesis. What does that mean? It means there's sufficient evidence to conclude that that mean from the first group is smaller than the mean of the second group. Yeah, pretty easy, right? All right, here's our word problem. So it's amount of time spent on the internet. So a general social survey poll back in 2010 took a sample of just a little over 1,000 adults, asked them how much time they spent on the internet. And so the sample mean was 9.79 hours per week with a standard deviation of 13.41. Second sample was taken in 2014, slightly larger sample. And then I kind of broke up the bolding. It says for this sample, and then says a standard deviation of 15.02, right? So it's implied, it's not as direct as it could be, but it's implied that they're using a sample mean. They're using the sample standard deviation. They're using the standard deviation of the sample. So boom, that tells us t-tests. And then it says, can you conclude that the mean number of hours per week spent on the internet increased between 2010 and 2014? Use an alpha of 0.05. All right, so 9A asks us to set up our hypotheses. So here, right, instead of ones or twos, I tried to be a little bit more explicit, right? Because you could set it up in two ways. Like it would make sense. Like half the class might make the first group 2014, and half the class might make the first group 2010. Neither way is wrong. You just got to be careful that you enter the information into the calculator in a way consistent with how you set up your hypotheses. So I picked 2014 as my first group. So I think the null hypothesis, always a statement of equality, essentially saying that the average time spent on the internet in 2014 is the same as 2010. Our alternative hypothesis, our claim, is that people are spending more time on the internet. So that would be equivalent to the difference in means being greater than 0, or if we shuffle it around, right, that the mean time spent on the internet in 2014 is more than that from 2010. Right, and so here I'm filling in all that information. So my first group was 2014, so I put all the 2014 information for the first group. I put all the 2010 information in for the second group. And then I think that mu1, the way I set it up, I think that mu1, the 2014, the amount of time spent in 2014 is more than that from group 2, the 2010. And then there we go. There's my test statistic. There's my p-value. Notice that it says 7.667, but remember, p-values are percents. They're always between 0 and 1, so it is not 7.667. If I look at the very end of that number, I see e to the -4. So that's basically saying take that decimal place and move it 4 places to the left. So it's going to be something like 0.000767. So it's a very, very, very small p-value. So just reiterating, our test statistic is t equals 3.17. Our p-value, I did a little bit of rounding, 0.0008. That's much smaller than 0.05. Since it's smaller than 0.05, we reject the null hypothesis. There is sufficient evidence to conclude the amount of time spent on the internet has increased between 2010 and 2014. Yeah, I got a little sarcastic there. So no duh, right? I don't think it's that surprising that people spent more time on the internet. I'm sure they spend even more time on the internet now than they did back in 2014. Because all the good stuff's on the internet, right? It's where our D2L lives, and of course our YouTube, and that's where we find all our narrated all our narrated statistics PowerPoints. So, right, if we want to go to a party, that's where we're going to find it.